Now that we've spent a lot of time talking about ways to visually represent our data, I'd like to spend some time talking about shapes of distributions of scores. One specific kind of distribution is called the normal distribution. You can see here that it is a specific shape, and an example of scores that are normally distributed would be your IQ test with a mean of 100 and a standard deviation of 15. The normal distribution is a specific frequency distribution that has three characteristics. The first is that it's bell-shaped, and you can see that here in this diagram, that it's shaped like a bell. That it's symmetrical. If I folded it down the middle on this dotted line, both sides would match up. And it's unimodal, meaning that it has one score that occurs most frequently, and it's right here at the peak. This is not the only shape of a distribution that we can have. So despite the fact that this is a normal distribution, we have other shapes as well. We have skewed distributions, which is how we describe distributions that are not symmetrical. Now you'll notice that these seem to be kind of mirror images of each other. And you'll notice that the mode always happens at the peak of the distribution. The median is the middle number, and it happens in the middle of our distribution. And the mean gets pulled in the direction of the tail of the distribution. And you can remember that a positively skewed distribution has its tail in the positive direction if we were going to number this from left to right, where 0 would be here or negative numbers would be here, and positive numbers would be toward this direction. And the negative skew then would have the tail pointing to the left, which is where we would have our negative numbers on a number line. One way to remember that is that the skew of the distribution is where the tail is. So this is your positive skew, and this is your negative skew. And the reason that the mean is the highest number on the positively skewed distribution is that if you have some really extreme scores, like somebody who makes $1 million a year, but the most people make in a particular community, say, is $45,000 a year, like most people make that, then that $1 million person will have the most influence on the mean, because the score that happens the most is not going to change a whole lot. And the median, the middle number, is really not going to change a whole lot. But that positive, that mean, because it takes into account every single piece of information, is going to get pulled in that positive direction. We can also describe our distributions by talking about how many modes they have. Remember that the normal distribution is a unimodal distribution. However, we have here a bimodal distribution. You can see it has two humps and that they are equal in height because these are two scores that occur the most. You can also have a multimodal distribution where you may have 1, 2, 3, or more even modes. And what this might suggest actually is that there might be different underlying populations. There might be some other variable that explains the differences between these modes and the fact that there are dips in between them, even though the average falls in the same place for both. The last thing that we can talk about when we talk about shapes of distributions is kurtosis. And what that refers to is talking about whether or not a distribution is tall and skinny, or tall and narrow, or short and wide. A leptokurtic distribution is a tall and thin distribution, where the scores don't vary too much from the mean, and they all seem to really pile up at the mode, the median, and the mean in the middle. A mesokurtic distribution will be a normal distribution. And again, there are specific properties that go along with a normal distribution that we will talk about in future chapters. And lastly, we have the platykurtic distribution. And you can think about the platykurtic distribution as being pretty short and fat, sort of like the bill of a duck-billed platypus. So here are some examples. of kurtosis. A platykurtic distribution, looks kind of like it could be kind of like a duckbill, versus a leptokurtic distribution, where you can see that it peaks very high and the scores are not as spread out. So those are some examples of kurtosis.